So we put like observed in line 1?
Yep, list 1, list 2. So if you're setting your TI up, list 1, list 2, observed and expected. It has to know expected too. Who's archived? Oh, Jackson, I didn't archive. That is a silly old command. I don't know why it does that. Unarchive. It's unarchived. Huh, must be it is. Did you already do it? Huh. Looks like it already was. Now, yeah, looks like it's gonna work. You already had the L1, L2, L3 figured out. What I'm gonna see, you'll see something different in L3 now. We'll go ahead and run the program list together. We'll show you what you're gonna get.
So L3 is...
Don't worry about L3. L3 will be filled for you by my program that I wrote for you. You'll see that in a second. 5, 5, 2, 3, 7, 2, 9, 5, 7, and then L2 is all 5s. Okay, beautiful. So L1 and L2, you can leave anything else in there, it'll take care of it all for you. So you got your observed, you got your expecteds, and everything else will get overwritten, so all is well, all is well. And you can use different lists too, but this is the way I usually do it. Okay, program, GOF. GOF for goodness of fit. The reason it's called GOF is because this is a goodness of fit test. Why is it called that? I don't know. I think it's because you're testing how well your data fits a distribution that you believe it fits. So if you believe the data should be randomly, uniformly distributed, you're testing how well it fits that data. I believe that's the I think that's the history of the name. So you grab that, and first thing it says, where is your observed list? Second one. Enter. Where is your expected list? Second 2. Enter. Boom! Done. You can! You can do it with TI, but it asks you for degrees of freedom. For some reason, which is not hard, obviously, Scott, right? It's not, you put it in 9, you put it 1 less in your categories.
It is wire now.
What error are you getting?
Dim.
Turn your plots off! Damn plots!
They are off.
What? How are you getting dim? Oh! I know how you are. You've got 1 less or 1 more in L1 or L2. Gary, it's a mismatch, right? Dim mismatch, or something about dim. Just check your data again, Jamie. Guarantee that's what's going on. Yeah.
When that happened to me, I didn't do it up on where it says L2. I tried to do it in like the first spot.
Oh, that's what you should do it. Don't do it on top of L2. Go straight down.
Yeah.
So I actually entered 5 10 times. 5, 5, 5, 5, 5.
Right. No. But when you're doing...
Oh, you said you put it up.
When you're doing L1 minus...
You don't have to. I didn't do... No, you don't have to do that at all. The program does that for you. If you go back and look, friends, look. Remember how I told you L3 would now be filled with something? It's filled with that final column that you guys did over there. So you don't have to do any, all you got to do is put your data in and put in what your data should have been ideally in. It takes care of everything else. Right? Merry Christmas.
I'm still archived.
You still archived. We'll take care of that in a minute. Merry Christmas.
It's just
Sounds good.
This is it. This is beautiful. This is absolutely beautiful. So now the reason I left L3 over here is in case we get deviant data. That'll help us identify it. And we'll talk more about that on Monday of next week. But we didn't get any deviant data according to our test because we got a huge p-value. It's 42%. Basically a coin flip. Is it random? Yep. I mean, nothing's being told to us for questioning the randomness. Lauren, what's on your mind? No, nothing. Take it all in. That's good. Please.
So how does that differ from if you go to tests?
It's good. Some of you with newer 84s, there's a built-in on the 84 that's called a chi-square GOF test.
Yes.
It's the same test. Mine doesn't give you a graph like that one does, but mine also doesn't ask you for degrees of freedom like theirs does. So it's my version of it. The reason I wrote the program, the reason I wrote it was because when I started teaching the class in the dark ages, the TI 82 and 83 didn't have any of it on there. They started adding it later. So that's why I just give it to you. That way if anybody has an older 83, they don't have to worry about not having the program. You can totally use that one if you want to.
And then
And you get the graph, which is nice.
sweet.
Yeah, and you get the graph, which is pretty good. Cool? Any questions about this? I do want to collect one more data set for analysis next week if that's okay. Only because I don't want to carry this stuff around with me anymore. And I had to haul it up here on my bike today, and I'd really rather not. And I just want to collect the data today. We'll crunch it next time.
So where's the number that tells us that it is not random?
Hold that thought till Monday. Yes. Well, not random, but not following the distribution.
Right.
Yeah, and it varies depending on the curve. That's the problem. It varies depending on the curve.
Isn't that just what you're going to figure it out?
Well, but Deanna is saying, like, where's the cutoff? The cutoff is going to vary depending on how many categories your data is broken into. This is a good point. You can show statistically that the Vietnam draft wasn't random enough in 1970, but it was random enough in 71, 72, and 73. If you talk about when guys were born according to quarter of the year, first quarter, second quarter, third quarter, fourth quarter. In other words, in 1970, too many guys that were born in October, November, and December were drafted. It wasn't random enough then. But if you break it down by month, the randomness comes back in again. So that's why I can't give you a final answer on that one, because depending on where that curve is and where the 95% of the curve is, governs where the 5% cutoff is. Does that make sense? Mathematically, it makes sense, but statistically, you want a line in the sand. The line in the sand moves because the wave that is that Goff curve moves. So you have to kind of just chase the area of the curve. Is that fair? Ish.
Yeah, I get that, but I just don't remember how you figure out.
Oh, you don't have to. This takes care of it for you. That's technology takes care of that for you. He makes us not have to chase that line in the curve. I'd give you a table if you want a table and look it up. But it's not worth it. Hold that, rephrase that for me in a minute. Just because I don't want to haul this candy in my backpack again. So here's what we're gonna do. I'll give you hand these around. With I heart candy, is that what you said? Well, here, grab a bag.
Make sure you don't have any take
Grab a bag of M&Ms.
Someone went to Costco.
I went to Costco. I got a second box just in case.
Candy?
Just in case.
Just in case. I think we have enough in there for everybody. I was depending on how many people showed up today. So here's what we're gonna do.
We were talking about this